that, and it'll automatically start treating it.
That makes sense. I didn't want to record a bunch of extra useless stuff at the beginning.
Yeah, yeah.
I'm looking at the tab where it's supposed to live stream it. Oh,
So you press your share screen on Zoom. If you press share screen, it's
that shouldn't control whether I'm live streaming or not, though, right?
yeah, like James just said, just press record to computer and it should automatically go to YouTube.
Because share screens, whether you're seeing my video camera or whether you see my screen. I will be doing share screen a lot during the meeting, but like that shouldn't control whether it goes to the.
Oh yeah, there. So let me check the YouTube one right now. Yeah, I don't know why the YouTube one's not syncing up. Oh, let me tell David. Maybe there's something on his end.
Oh, there we go.
Oh, is your work?
Yeah, YouTube. It adjusted. Okay, there we go.
Okay. Yeah, he just said it takes a bit to load in.
Well, I think.
Yeah, it was like a little bit of a delay when you use YouTube. So.
And I obviously should turn my YouTube volume off, otherwise it's going to drive me crazy.
Yeah. It's about a 5-second delay.
Yeah. Okay, well, it's working now. It's good. I think maybe you have to have record first before putting in the live link thing. I think it failed because I wasn't recording currently.
Oh.
Whatever. We got her now. Now, is that actually Fula or is that Dimitros?
They should be all real names, so I don't even know.
Well, no, wherever you log in as, right? Like,
Yeah.
so if Fula was in a meeting earlier, right? And Dimitri gets on using the same computer, it's going to say Fula. Like I've certainly had meetings I've gone to where I've been named Christine.
People should be joining in a bit to get a decent amount of people.
Who's Ramen, by the way? It's too common of a name. It's a secret? Okay.
Yeah, it might be someone not from Mass.
Oh, that's possible, yeah.
Yeah.
I certainly have taught a few ramens.
Yeah, seriously, if you look on the YouTube chat, like people are commenting and stuff right now. So
Okay.
yeah, like Mirage, Chen.
Making comments like, you look lost, sir. Oh, just hi, sir. Oh. Okay, here we go, 3 o'clock.
Yeah, so you can start.
Yeah. Okay, so you're gonna get a bit of a lag if you're on just the YouTube, as you've read in the comments, hopefully. Okay, so the way I see this session is going to be a Kotlin experience. Kotlin's a big language. I certainly cannot teach you to become good at it in an hour and a half. So instead of going through the process where I teach you to be mediocre at it, where I go through the very basic building blocks and try and bring you up to the point where you can write an okay program. Instead, I'm going to throw you in and give you an experience for what Kotlin's all about. Okay, so the first thing we want to talk about is why Kotlin? There's loads of languages out there. Why would I suddenly say, Kotlin is worth looking at? If you look at the TIOBE index, Kotlin's around 29th, which doesn't jump out and say, hey, that's a up and comer. Here's how you know it's an up and comer. So first, the prevalence of the IntelliJ IDE. That's keeps gaining preeminence. Loads of people are using it. Loads of people like all the features in there. So the guys who made IntelliJ are the ones who made Kotlin. They are, excellent Java programmers, and they decided that the features in Java just aren't there. So what they've done instead is they made their own language that has all the modern features they want, nice and concise. Now, Kotlin uses the JVM, the Java Virtual Machine. So anything you produce in Kotlin will run on any machine that uses a JVM. So if you can run Java, you can run Kotlin. And of course, with an IntelliJ IDE, you can actually go back and extract the bytecode and see what it's doing exactly, which is nice. Okay, so where we're going to start? Well, let's start with going to play.kotlin.org. So as you can imagine with this workshop, you need to follow along to get something out of it. So if you go to play.kotlin.org, and then from there, if you expand it a bit, you'll see we have these 4 sections here. The playground. Now, we're not going to use the playground that much. We're going to jump back and forth to it here and there when we want to explore deeply some ideas that we encounter. There are hands-on. We're not going to look at this at all, but in terms of going forward, if you want to get good at some of the things that Kotlin is used for, this is the place to go. Now, it's worth noting that Kotlin is the first language past Java that Google has allowed to be used for Android development. This is a big deal. With libgdx, it's the first language past Java that is supported by libgdx. So it's gaining support quickly. So in this hands-on area, you can pick a project and really go deep into stuff. Examples, as you're going through and you're struggling with ideas, you can jump to these examples and get deeper examples of what's going on. Now, the area we're going to spend most of our time today is in koans. Now, a koan, it's a Zen Buddhist thing. It's a riddle designed to teach you an idea. Okay, so to get to this next step, you need your window open, playkotlin.org, go to the koans, and I need you to be right here at the first koan. Okay, let's. Okay, so how are we doing? I need to know if you're following along in some way. I need to know that you're at the Kotlin koans. Again, the Zoom link is much better. It's much easier to chat with the type in real time. I can read your comments and see that you're following along, but you'll lag behind. The Zoom is better. Okay, so I need you to be at this stage. Okay.
Yeah, so I think everyone's following now.
Okay. Okay, so how do we do this? Well, I can close that, I guess. Okay, so here you are at the Kotlin koan. So you read over to the right, take a look at function syntax and make sure that the function start returns the string okay. Now, at this point, you may be able to just kind of figure it out. But just guessing at it isn't really a good approach. Neither is just clicking on show answer for each of these. You're kind of wasting your time if you do that. Okay, so the first thing you do is you give a click over on this, and you give a quick run through. What do the functions look like? Okay. So it does tell you that the main function for Kotlin looks a lot cleaner than the Java main. Okay, it's just, there's no class. So Kotlin's kind of like Python in the idea that it's not being pure when talking about, paradigms. It's not purely object-oriented, it's not purely imperative, it's not purely functional. It mixes elements of each of these to get the results it wants, and that's a good thing, which makes the main very simple. Okay, so for each of your functions, so it's not def like Python, it's not just nothing like Java. Fun, okay, that's easy enough. Feels more like Python, right? Fun, sum. So you give it the parameters and the return type. Easy enough. We'll talk more about the types here. You notice they're all capitalized, which tells you should know that means they're all classes, right? You should recognize that right away. Okay, so the name of the function's here, parameters here, return type is here, body, of course, there, return A plus B, easy enough. Now, one of the frustrating things when you start learning Kotlin is that there are multiple ways where you could express things. As you get better at it, you start to realize, oh, these are, clean simplifications that Kotlin can figure out. So for example, if all you're doing is returning a value, you can say your function equals that value. Now, when Kotlin can figure out the type from the return, you don't need to put it in. So these are the exact same function. Kotlin sees this and says, oh, A is int, B is an int, A plus B is an integer. So this function is returning the value of this, which once you get used to that, it's pretty easy. Okay. Print sum. String formatting in Kotlin. Okay, two things here. :unit. Unit is basically the same as void or null, or void, null, none. No, not null. Null's still here, sorry. It's basically the same as void in Java or none in Python. And the thing is, if you're not, you can eliminate the :unit. I've never put it in. I don't see a point. Okay. String formatting is straightforward. If you want to break out of the string and use a variable, you just use $ and the variable name. You don't need to identify the type of it. If instead you want an expression, $ curly bracket, and whatever expression you want goes there. So that makes it nice instead of these opening the quotes and closing the quotes all the time, or using escape characters or string formatting. It's very elegant string formatting. Okay. Variables. Two important things with the variables here. They can be val. That when you compile that will get compiled to public static final, or based on the scope of it. But yes, this is an unchanging variable. It's just a value, which makes sense. Now you'll notice here, okay, here you're saying that it is A is an int and it starts with the value 1. And again, Kotlin can infer things. So B equals 2, it figures out it's an integer. If I wanted it to be a double instead, I'd put 2.0. Okay. And see here, obviously it's saying that it can hold an integer, but it has no value yet. And we'll learn later that Kotlin's a real particular when it comes to null values. Okay. Var is a variable, so it can change. Simple enough. Comments, same as Java, no big deal. And we've gotten past our function stuff. Okay, so we go back to our Cohen. By the way, when you look at these things, if you hold Control down and click it, it opens a new tab instead. It's a little easier. Okay, so take a whole 30 seconds and you figure out what to put there. I'll use that as 30 seconds to check into my. Okay, so hopefully we tried a couple of the options there and you realized okay, get out of that, get out of that. And that. So you realize this thing returned a string. I want to return the value okay. Start colon string equals okay. Now, we could have gotten rid of the string here. The only reason I didn't is because that was like the string was already there before the to do section. Okay, so we run this. It says, hey, it worked. Let's supposing, just for the sake of argument, let's see what it looks like when it doesn't work. Like maybe I wasn't thinking straight and I said not okay. I run that, it's going to say, oh, hey, I was expecting okay, but you gave me not okay. And if you're stuck on one of these, you can click show answer. And it's saying this is what you replace the to do with, which is the value okay. And if you want to reset it and try again to see if you can do it, there you go. Okay. So hopefully how to use the cones makes sense. Next one. Okay, so it goes into default and named arguments. And again, we're going to zip through a bunch of Kotlin stuff here, not with the hope that you can program Kotlin by the end of this, but so you can see enough Kotlin to convince you that it's worth investing your time to learn these. Okay, that's the whole goal of this entire workshop. Okay, default and named, so we jump into that. And okay, there's our functions, yada, yada, parameters, we get that. Default arguments. All that is the default value for the argument. So if I say off equals, off is an int. Okay, so this is a byte array, obviously. I haven't got into that yet, that's okay. But we're saying the offset starts at 0 and the len, which is an int, equals b.size. This is interesting too. Not only is it a default value, but it's using an earlier parameter to get that, which is kind of interesting. So the idea being, when you call the function, if you leave off, okay, I don't know if that's obvious. Okay. No, there it is. And here is where I'm going to go back to my playground for a second and have a look at this. So as you're going through the help, if you don't quite understand something, go to the playground and try to make sense of it. And now you don't know how to make a byte array yet, so let's just say, let's just make this a string. And strings don't have a size. So we're going to say b equals some random value of 5. No. Sorry. And so I'm saying this whole function, it's not going to return anything. It's just going to print line. And I'm just going to print when I get in. I just want to experiment with default values here so it makes sense. So I'm going to say $b starts at $off goes to, well, if it's len, it probably doesn't go to that. Probably is off plus len, but whatever, don't particularly care. Okay, so obviously this is not what a read's supposed to do. So if I say this is a test 310, and I run this, it says this is a test, starts at 3, goes to 10. Okay, so if I only give it one integer, which one does it take? Okay, so if I leave one off, so if I leave them off, it's from the right-hand side, right? It's 2 integers here. And so I could leave them both off, and it's going to go from 0 to 5. And this is standard operation for how default parameters work. I was actually shocked when Java didn't have them. I'm like, what? Default values are awesome. Default arguments, yeah. Okay. I don't want to get sidetracked with overriding functions just quite yet. Okay. We're going to get into this. You may have seen this if you've done it in Python. You might not have. But a Lambda is an unnamed function. Okay, what it's saying is with a, oh, did we get the named yet? Oh, we'll get to the named in a second. Okay, so for Lambdas, if you put the Lambda last, you can actually call it by putting it outside of the parentheses. Or if it's the only one, you can leave the parentheses off. Okay, so this looks goofy, so let's look at it. It's a little too involved. Back to the playground. Let's look at this function. Okay, so this stuff. Okay. Okay, so the way this function, this function is kind of weird. It's saying we have bar, baz, qux. Okay, so this is an integer. This is an integer. Qux is a function. That's this notation saying it's a function that results in a unit. Okay. So now when I call these, let's look at them one at a time. Okay, so if I pass it this way, I could pass it as foo 1, 5, and then this is looking for a function that returns a unit. Okay, well, print line happens to be a function that returns nothing or unit, and that's what it's saying there, right? Okay. Well, apparently I don't make lambdas very well. Okay, we'll get back to that. I don't want to get sidetracked on my lambdas. Okay, the point is, if you have a lambda, you can either define it in there. Oh, yeah. With a lambda, you need these curly brackets around it. That makes it. Now, there's no content to the function, so it's not going to do anything useful. If it even runs. Okay, let's not get sidetracked to lambdas. Okay, so named argument, this goes along with, let me check my, okay. The named argument goes along with your default arguments. So when you have a bunch of them, this whole dropping from the right can be annoying. You have 10 arguments. Supposing you have some GUI you made yourself and you want to supply all these parameters for how your text block is going to work. Well, you don't want to, it's hard to figure out which one should be dropped at the end. So instead, what you can do is use named arguments. And all that's saying is when you call them, you can just say, like here, if I said, okay, so this guy has to be given. If I wanted to, okay. So my Lambda goes last and it can go outside the brackets. And here, if I wanted Baz to get the value and not bar, I could just specify. Okay, so named and default go with each other. Okay. And we're pretty confident we have a basic idea of what's going on there. And we go back to our Cohen and we ask ourselves, what's going on here? Okay, so it says there's a join to string here. If you're not sure what that is, you go control, join to string. Real quickly, it says, there's this join to string, which acts like join from Python, right? Not a big deal, but it has all these parameters. So here they're trying to get you to play around with the named parameters. So all you do is find the right ones. Back to our Cohen. Okay. Now, they want this stuff, options, joined such that it looks like this. Oh, ridiculous. I had my answer there already. Sorry. Okay. So it's already options.join to string. So then you look at your parameters. I hope you didn't study mine yet. So take 30 seconds and see if you can figure out from these parameters, which ones do you need to set so that it does this correctly. Now, if you look in here, they all have default values, right? So separator is already comma space. Don't change separator, it's already right. Okay, so hopefully you're like, well, prefix looks like I need a square bracket. And postfix, I need a closing square bracket. Give it a test. Hey, look, we got it. Aren't we amazing? Okay, ignoring my fumbling on the lambdas. Okay, next one. And let me make sure I don't have anything there. Okay, good. So we'll give it a look here. Several overloads for foo in Java. We're saying we can accomplish all these using just default arguments. Okay, so you have to look carefully at this. We have this function here, foo. Name, number, to uppercase. And it does this. We don't particularly care about that. Well, so all of these have to be done by giving default values here. So we look at this list here. Every single time we supply the value for name, that's telling us probably don't want to replace that with a default value, right? Because we give it every single time. Okay, so I look at the first one here. Number is not specified. I go here and say, when I don't specify number, what do I use? Oh, 42. So you go here and you say equals 42. Same thing here. When I don't specify the to uppercase, what do we use? Well, we use false, right? And so name doesn't get replaced. It's always supplied. Number could be 42, as it says here. Boolean could be false, as there. This. Okay, so what's the type of this function? Oh, we haven't talked about this. Okay, so the if statement in Kotlin isn't a statement at all. It's an expression. Okay, so in Java, you have your conditional operator, which is your question mark and your colon, and that acts as an expression that gives you all the functionality of an if statement. Well, in Kotlin, even your basic if, let's go to the playground for a second and talk about this. So if I have var x equals 5, it knows that's an int, has a value 5. If I say if x less than 10, print line, small else print line big. Even in this case, this guy is an expression. It takes on the value of whatever's on each side, which means I could say var y equals. Now, print doesn't return anything. So if I print line my y here, it's going to be a value unit, the none value, right? Okay, Kotlin.unit. If I just put values out in space, when I run it, the last value in the branch assigns the value to that branch. So this branch gets that value 12. Okay. Now you're not going to typically do this, but there are times you'll do similar things to that. Okay. All the way back to our Cohen. That's what it's actually doing. It's taking on either, so yeah, if this is true, it takes on this value, else it takes on this value. Not that it matters for this Cohen. We just have to match the parameters, and we pass that. Okay, the next one. Okay, talks about, we have some functional programming on here. And here's the lambdas, which I fumbled with already. Okay, so we're going to pass a lambda to any function to check if the collection contains even numbers. Okay, so this is some collection.any. So how the any works, by the way, hopefully it's obvious. It looks at the collection and asks, does anything meet this criteria? And you have to, okay, by putting something in these curly brackets, not only does it act as a flow of control, but just the curly brackets themselves act as a lambda function. Let's have a look at this lambda stuff. Okay. Of course, I start off with a complicated example. With generics already. Maybe we don't want to talk about that yet. Okay, so this, I want an easy example. Okay, okay, so this is an example of a simple lambda expression. Okay, so what are we talking about with lambdas? So we'll go back to here. We don't need that. Okay. So X. X is a variable. It has a name. If in my code, rather than saying if X greater than or less than 10, as far as this code is concerned, it's the same as if 5 is less than 10. Okay. So 5 and 10 are both anonymous integers, whereas X has a name. Now we can do the same thing with functions. So I could have okay, so I could say I can make a function that, let's call it add1. What a clever name. And it could take in some integer, and it equals that integer plus 1. Okay, so be careful with this playground. It likes to suggest things that are stupid, like an and for no reason. Okay, so add1 is a function that takes it in an integer and returns that integer plus 1. So if I say val x equals add 1 to the value 5, we're not surprised to find out that x has a value 6. Like, that's not surprising. Okay, this is a named function. I could use an unnamed function. It just says I goes to I plus 1. If you can't infer the parameter, you have to tell it what it is. So some integer I goes to I plus 1. This is the unnamed version of this. Okay. Okay, so that's some of the stuff here on the higher order function talk's a little too complicated. Okay, we're back here. So the collections.any, what it takes as parameter is a function. So you could think of it as these, okay, you're used to parameters having parentheses. But in Kotlin, again, if you only have the 1, you can leave the parentheses off and it can figure it out like, oh, I see you have a Lambda function here. Obviously, you mean that's the parameter. Okay. And hopefully this is easy enough. It's going over the collection. It's a collection of integers. All you're saying here is, okay, so you're taking some I, which is an integer, and you need to figure out if it is even or not. And that's just I mod 2 equals 0, right? So that should be fine. And I think there's a nicer way of showing it, so I'm going to look at their answer. It mod 2 equals 0. Okay. So the default way of doing this is if you only have the 1 parameter and you want to say, I want to talk about that guy, whatever it's passed in, you can go right to the result. And the parameter is referred to as it. It's like a this. This is the current object. It is the current parameter. And so at first, when you start off with Kotlin syntax, you're like, oh, there's so many different variations and it goes down so small. But once you get used to it, once you can actually read that, it's better. Okay, our next colon. Okay, so hopefully we're pretty comfortable with playing with strings. We go here. String literals. Okay. Hopefully you're not surprised that your string consists of characters. Cool. Hey, look, the triple quotes are back from Python, right? It allows you to put anything inside of there. It's nice. Rather than considering them multi-line, they're called raw strings, but it's the same effect, basically. One of the cool things I like about it, this trim margin, I always had this problem in Python where you start the line here and all of a sudden it, everything else is tabbed over because you want your text to go nicely. But you can trim the margin, and by default, it's using a horizontal bar for that. You can change it as it's suggesting here, but that's pretty cool. Minor, but cool. Okay, string templates, we've talked about that. You can substitute the value in, or you can substitute an expression in. Okay, so pretty minor stuff there in that. Okay. Now, when you read this, the first time I thought it was asking us to actually do a regular expression. All it's saying is, let's generate the correct pattern to identify the regular expression. Okay. Now, if you're not used to regular expressions, what it's saying is, okay, the escape says, okay, let's escape to the special character. D is for digits. So we're saying 2 digits, a dot, 2 digits, a dot, 4 digits. And what they're saying is, get it so it matches this format. 2 digits, any month, 4 digits. Okay, this is the way you say any month. These act as logical ors in regular expressions. So it's saying this or this or this or this or this or this or this. So basically all it wants is this stuff with this replaced with a string. Okay, we'll give you 30 seconds to play with that. No questions on YouTube. And is there a nice way to see questions on Zoom while I'm sharing my screen? I don't know. I'm going to suggest if you have questions, throw them on YouTube.
Yeah, sir. No one's really commenting on Zoom, so you should be good.
Okay. And I'm going to avoid putting myself on my screen with myself because it looks super weird.
Yeah.
It's like that time you're in an elevator with 2 mirrors.
Yeah, like the infinite mirror thing.
Yeah. Okay. Did we get the thing, everyone? Hopefully you realized. Okay. All they're asking us to do is say the pattern equals this, but rather than here, we want this to be this guy here, and that's simply $month. Try that bad boy. Oh, yeah. Not dots, spaces. And their answer, I thought it was weird. With their answer, they unnecessarily use curly brackets. Curly brackets is when you want an expression, not just a value, but whatever. Okay. So to understand this example better, you need to know Java, but that's okay. Most people here do. Okay, rewriting this as Kotlin. We have a person class, has a name, has an age. We assign them, and we have 2 getters. Okay. Then add the data modifier. So the classes in Kotlin are really cool. Let's have a look at them. Okay, so you can make a class. It'll let you do this, just make an empty class, just class empty. I don't know how useful that is, but okay, so rather than having the same name as the class to be a constructor, it's called constructor. And the primary constructor, you can have primary and secondary constructors. So the primary constructor goes in the function header itself. And you put the the variables in the brackets of what you want to assign. Okay, so it'll assign properties for each of the ones. There's a minor distinction between property and field in Kotlin, and we'll get to it in a little bit. Okay, so basically, if I had this as my constructor for my class and nothing else in it, I'd be able to already just pass in a string when I make it, and it'll make an object that has first name as the property. Okay. If you want to use the primary constructor and you don't want a secondary constructor, you can add code to it by using init. Okay, so it's an initialization block, the kind of stuff you would have normally in a constructor. Okay. You can, when you're making them, you can define each of your properties as var or val. Again, that's an easy way of handling whether they're read write or read only. You can add secondary constructors. Let's not get sidetracked by that. I don't want to get sidetracked by inheritance. Okay, so for each of your fields or your properties in your function, you can assign how much control you have over the. Let me. Blah 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 blah. Okay, so real quick here, I'll show you some classes I was playing around with. Okay, so if I have a person class, I can set, so rather than relying on a primary constructor, I just went to a secondary constructor here. So each of my fields, I have name and a, so my class has a name and it has an age. Now, if I don't want to allow anyone to set a value, I could make set private. I can also change how get works. Okay, so these properties, when you access them, it looks like you're accessing variables directly. Inside my main here, okay. So if I say class A, clever name, yeah, I know. And I have var x so here I make an object of type A. So I say var object of A equals an A. So if I print line my object of type A dot X, what it's actually doing, if you go into the compiled version of this, you look at the class, the bytecode, you'll see that it's not actually directly modifying a variable. Instead, this thing has a backer field. Well, it's not even modifying it yet. I'll get to that in a second. Okay, let's look at this. Now, for this field, it already puts in default getter and setters the way you would in most things. And 95% of the time, that's all you want. So Kotlin says, let's not waste our time with that garbage. But let's supposing for some reason, when I get, I don't want the value X, I want 1 bigger for some reason. Okay. Oh, what is it? Okay, so again, what I was doing there inadvertently was I accessed the property. So the property calls the get, which calls the get, which calls the get, which calls the get in Stack Overflow. Okay, the underlying field is the actual variable. So supposing I didn't want to give the actual value of X, but I wanted one bigger for some reason. And control how I set it. Supposing I pass in some value V, I think I'm doing this wrong. Need that or no. I got my sets wrong. Anyways, you can control how the setter works by doing this. By default, leave them off. You give you default getter and setters, exactly what you do for 95% of your code. Okay, one last thing. When I print the object, it tells me it's an A at this location. And as I would normally do, I could add a toString here, as I would do from Java. Now, the primary constructor version of this looks like that. So when I make I need to type needs a Kotlin type. Okay. Now, when I make it a value, I can pass it in and I can give it a default value of 0. When I don't specify a value, still ugly. Now watch. When I make it a data class, I'm saying it's not really an advanced class, it's just holding data. It's kind of like a structure from C. When I do that, it provides a bunch of useful functions like equals, copy, and toString for me, hash code also right away. So the toString will just give me the default values. Okay, back to our Cohen. Hey. Okay, so we have to rewrite this so it works in Kotlin. Okay, so I have class person. Person has a name and an age. So it seems like here that's class person. Oh, yeah. Name, string, age, int, let's go for a data class here. Oh, it needs to know whether variables or values. And in this case, I don't think it matters too much. And there we go. I want to see what they use for theirs. They use vals. I don't know what we're using the guys for, so whatever. Okay. So again, one of the strengths of Kotlin is the reduction of boilerplate code. So when you make a class and you want to, all you're having to do is you're having like a shot that's going to move around the screen. Like you don't want to put all that code in yourself. It'll do it for you. Okay. Null safety and safe calls. if you've been doing Java for any length of time, you've come across a null pointer exception. It's super common. Now, Kotlin tries to prevent this at all costs. Now, the problem is there's loads of different little tricks that you have to get used to get used to this. Okay, so newer versions of Java do this as well. So you have to basically make it clear whether this variable can hold a null or it's not nullable. Okay. So our default operation in Java is to throw null pointer exceptions, and this can be painful. Okay, so we look here. By default, your default types like string cannot hold a null. Okay, so as it's saying here, if I run this, it'll tell you that you can't hold a null here. If you want to declare a type where you say, hey, it's okay to hold a null for this guy for whatever reason, because sometimes we need things to be null. That's just, you know. So you use a question mark after the type. So it's like a string, huh? Like maybe it's a string, maybe it's a null. I don't know. That's what it's saying here. So it's okay to make it null. All of the basic types in Kotlin are actually classes. Now, you might, it's a bit of a sidetrack, I know. You might look at that and think, but Java uses primitive type for efficiency reasons. The truth is, what the Kotlin compiler does is whenever it can use just a primitive type instead, it does that. If you look at the class, the bytecode, it'll actually optimize it and still use primitive types. It only uses the wrapper classes when you need them, which is much better than leaving it to the user to decide, because as soon as people realize, oh, there's an uppercase B Boolean too, I like that one more. And people use that all the time for no good reason. I'll never even teach it, and people are using it everywhere. I'm like, no, you use lowercase b, it's more efficient. Kotlin fixes that for you, which is very nice, I think. Okay, back to here, nulls. Okay, so because these types can't be null, so this is a safe operation. It also can't be null, right? Now you can still check if something's null. Okay, we're getting back over to the safe calls here. This is when you call something that is null. Okay, so I'm saying B can be null because I said it could be. So if I want to access it, I use the question mark to make it a safe call. So rather than giving a null pointer exception, what it does is it makes the whole expression null. Okay, let me go over that one more time. So if B is null, and I use the question mark when I access it, rather than giving a null pointer exception, just this whole thing becomes null. Okay, and that's going to help you along the way. It doesn't fix null pointer exception, but it certainly helps reduce it. The problem with null pointer exceptions is that they creep up and bite you not looking. Okay, so there's that operation. The Elvis operator. Okay, so this is the Elvis operator. Question mark colon. Maybe you don't know who Elvis is, but he had iconic hair that was kind of swooped in front. And so if you look at this guy, it looks like Elvis. That's why it's called the Elvis operator. Okay, so what this says is, so the value of this expression is this value, unless this value is null, then use this value. So the Elvis operator says, if what comes before me is null, use this value instead. Okay. One last operator is the double exclamation mark. I've found when I'm just trying to get things done and I'm still thinking in a Java mode, I tend to use this operator quite a bit. It's not the best operator though. Basically, it's saying do things the Java way. Just crash. If it's null, just crash. I need to get better at them, but that's the truth of it. Okay. So save casts. You can, yeah, it'll cast it if it can, otherwise give a null. Okay, back to our code. Tough to read this one, a lot to it. Okay, so it's saying, now we haven't taught this nullable decorator. Basically saying they want this to work with only one if. Oh, sorry. Okay, so what's going on here? We've got this class, client. Okay, so our function, send message to client, has to work. Okay, we got a lot here. Let's separate it a bit. Okay, so I have a client, which, as you can see by the question mark, my client could be null. I have a message, which again, could also be null. I have a mailer, which as you can tell is not null. No question mark there. Okay. So here, when I look to the right, you can see the end result is, I'm going to check for, okay, client. So in Java, I have to check if either one's null, don't bother doing anything, return. Okay, so each client has personal info, which is of type personal info, which might be null. And then I have an email, which could also be null. Okay, so basically I have to send this email with this message without any null pointer. No null pointers, yeah. Okay, so the mailer is an interface. So it has this function, meaning the end result of this is I want to say mailer dot send a message, which could be some string. I don't know where to get that string yet, and some message. Hey, this is the message there. Okay. So I got an email. Who has an email? I look at the client. Client has personal information. Personal information has an email. So basically, I want to say it's client dot personal info dot email. Okay. And now we got to start caring about the nulls. Not string comments, it's just message. Client has personal info, has email. Okay, so it's complaining because it says, hey, dude, email could be null. You know that, right? This message here says, take a string that's not null, take a message that's not null. Okay, and both of these could be null. Okay, well, let's, this line here is getting a little messy. So let's say val email equals this. Now, I could check each of these as I go and say, if client's not null, if personal info is null. But that's the whole idea of these question mark things. So if I do that and that, I have two options here, right? Either I get an actual email string or I get a null. And message itself could also be null, right? And there's no, this won't accept nulls. So here I have to resort to using an if. So if email is not equal to null, and, okay, be careful. You're going to find that AND is also an and in Kotlin. AND is the bitwise and. Ampersand, ampersand is the logical and. and message is not equal to null. Okay. So what has Kotlin done for us? Well, it's forced us to write good code. In Java, we wouldn't, oftentimes we say, yeah, whatever. I'm sure it's probably not null. I'm just going to run it. And maybe it works, maybe it doesn't. Or maybe you get a null pointer exception, a month down the line when something else is happening. Kotlin forces you to make safe code. If you're saying here, you're taking in strings, it's going to be darn certain you're not passing in invalid strings. Okay, let's check if I got it right. And no surprise. And there might be a different answer that they give, but I think this is as clean as I can get it. Okay. Smart casts and a when expression. Okay, smart cast. The cool thing about this is if you check if it is a string, now this is inheritance, right? So any is the ultimate superclass in Kotlin. So obviously, so this is equivalent to capital O object in Java. Okay, so it knows it's a string, so it'll automatically access string stuff with it, which is pretty cool. Okay. Even in this case here, if you say, if it's not string, return, it knows, oh, obviously it's a string, which is pretty cool for the compiler to be that smart about it. Same thing with like the right-hand sides of ands and ors. Okay, the when corresponds to a case select structure in Java. In other languages, many of you know I don't bother teaching the select structure. I don't teach it because it's a go-to statement where you need to have a break for it to work correctly. The number of times people forget the break and their code falls through to the next condition, I taught it for years and I just stopped teaching it. I'm like, this error is way too common. You don't have that situation with the when statement, so I would use it. So these are just conditions that go in order. So this whole thing's an expression too, by the way, like our if statement. So it'll perform this operation, but it'll also, it'll take on whatever value it takes on. Okay, so, and this is all, the when here is all using, oh, yeah, you'll notice there's an implied x is int, right? Okay, so let's go back to the colon and see what the heck it's talking about. Hey, where'd my colon go? Maybe I lost it. Smart casts. Okay. Rewrite the following using Java smart casts and a when expression. So it looks like it's pretty much already written for me. Well, let's revert then. Maybe I already, that makes sense. Okay. I gotta get a habit of reverting them all. So I have some interface expression. This just tells you it's an interface. Okay, so I have this class num. This means inherits from, same as from Java extends. So what I'm saying is that num is an interface. Sum is also, oh, sorry, an expression. Yeah. Okay, so when I pass these in, if you look here, we say if it's a num, we want to get its value. If it's a sum, we recursively call eval to get the value of the sum. We recursively call eval on both left and right-hand side So if you're not sure what this is like a binary tree. We did binary trees. You recall I talked about how the postfix is not particularly useful for a binary search tree, but it is useful for a binary expression tree. This is a binary expression tree. The expression it handles is just sum. So it's not that interesting. Okay, so if it's a number, so I pass in an expression, right? So I pass in either a num or a sum. Now, if it's a num, I just want to return its value. Okay, so the value is just expr dot value. In the sum here, it said do it recursively. Let's see. So I'm going to recursively call eval, and I'm passing in whatever I get to the left, right? So this is going to be expression.left. And we can test it. Okay. I'm not certain you guys get what's going on here, though. I'm going to just take it off to my sandbox for a second. And which I probably closed. And let's look at it. As you're going through these koans, if it's not obvious, I'm not going to make it through the whole thing. I'm showing you the process, how you can go through them yourself. But when you do a koan, if you get it right by fumbling around, bring it to the playground. Make sure you really understand what's going on here. Okay. So I have a var. Okay, so var x is a num, which has the value 5 in it. Hey, what's your problem? X is never used. Yeah, good. Oh, sorry. Equals num. And print line my eval of x. Run this. Okay, so the number's a number. Hopefully that's not shocking. So var my expression equals a sum. Okay, so I'm making, let's take an x for my left and a sum taking in a num and a num. Okay, so this makes an expression tree where if I run it, a eval my expression instead. And again, this just makes my x equals basically 5 plus 23 plus 10. That's all that's doing there. But it does do this bracket part of it. That's why you have an expression tree. Obviously, if it's just addition, it's not very useful, but it would be useful if you added all the basic operations to it. Okay, that one's good. Next koan. Nothing going on with my. Okay, extension functions. This is one of the things that really got me excited about Kotlin. Okay, so an extension function is you have the ability to add a function into an existing class. So you can add a function that modifies how int works, and now all your integers can do that. You can modify how string works, how list works. To me, it's a game changer. It's not just you take in a function, you take in a value into a function and do something with it. You actually embed the function into the class. Okay, so let's see how that works. Of course, the first example is a little complicated, but okay, so they haven't introduced collections yet, but this is how a collection looks like. A collection, it corresponds to, okay, so each of your collections are either like, so for your list is either a mutable list or a regular list. It basically it's your array list, but it builds in that var val capabilities. Okay, so what I'm saying here is, so for mutable lists of integers, we're adding a new method called swap. And hopefully this is straightforward. So the this is the current list we're talking about, corresponds to it for the Lambda functions. Okay, so this is the basic swap method. Hopefully you've seen this before, where I get the current index, I put the index 2 into there, and I put the temp back. Okay, it's like juggling. This goes a temp, this goes there, that goes there, right? And here shows using it. Okay, so the key is you put the class, you put the new method name, and you make it like a regular function. Okay, did I forget to hit control? Probably. There's my colon. Okay. So we have this data class here called rational number. It has a numerator denominator. Oh. Okay, so I want to build in an extension function for int such that it can convert them to this rational number. Okay, so hopefully you know if an integer has a value like 5, then the equivalent rational number is 5 divided by 1. Okay, so this equals, so again, this is the method name, the .r. So it's going to make a new rational number, passing in this as the numerator and 1 as the denominator. And pair is a new type you haven't seen. There is pair and there's triple. I haven't found a quadruple yet, but those are nice, useful classes. Okay, so when I make so it's a rational number, it equals a new rational number. Okay, so the cool thing now so you could say this dot, so it's first and second for rational numbers, for pairs, I mean. Now the cool thing is, now this should work, that this is implied. It's like, what else are you talking about? Of course, it's this dot first, this dot second, which is pretty interesting. If it's not obvious what's going on here, it might not be obvious. Let's bring it over to the playground. Okay, so what I'm saying is, val x equals 5. Val x as a rational number equals x dot r. Okay, so the ability to modify built-in classes to me is a game changer. We can modify how pairs work, modify how integers work, we can modify how other classes work, and that's pretty useful. Okay. Object expressions. As I see time is running down, I'm going to start skipping over stuff that I think are not as important. Object expressions didn't blow my socks off, so I'm going to skip them. SAM convention, same. Extensions on collections. Okay. Hopefully, despite the fact that we kind of lost the Java collection framework unit, you're gonna recognize the importance of collections. And so real quick, look at this. Okay, so the even though the mutable list comes out ultimately from an array list, the way they restructure things in Kotlin, they view it as array list inherits from mutable list. That's just so it just makes it easier to pass things in, because obviously array list seems more specific than mutable list in general. But obviously you have, as you'd expect, you have lists, you have sets, and you have maps. I don't see the maps here. Okay. I don't want to get lost in the Kotlin collection framework. Let's just see what the cone is. And I forgot to hit control. Okay. So rewrite the previous example once more using the extension function sort descending. Keep forgetting to revert back. Okay, so you click on here, you hold control, and you say, what the heck is up with this? Sort descending. And you're like, okay, well, it looks like all these arrays can sort descending. So as you can see with your collections, you have these, for each collection, there's a corresponding method that can make an instance of that collection. And those are pretty useful, as opposed to Java, which making a standalone array list is a bit of a pain, right? You have this arrays out as list stuff, where array list of, I think, is pretty straightforward. Return list sorted descending. It says here there's a sorted descending. Nope. Let's try that. Okay, so wasn't much in that cone. Now, our time is running out, but you can see there's a lot more to do here. What I've hoped to expose you to is the process of going through these cones. I think we're going to get 2 more done, and again, I hope I showed you enough to make you want to look further. Okay, but this is a big deal to me. Operator overloading. I used it quite frequently when I was doing C++, and I was a little disappointed that Java didn't have it. So I'm happy to see that Kotlin has it. So basically what we're saying is when you make your own class, you can make operators that make sense. So you make you know, a bad guy class. You can, you know, for some reason like bad guy minus good guy, you know, equals something that's useful, or bad guy minus bad guy, or bad guy plus bad guy. You know, like they don't all translate, but there's obviously situations where like a date plus a date, like that makes sense. It should make a date, and you can make that happen in Kotlin, and that's a big deal. Okay. So what do we have here? So look at the convention, how it's actually done. Okay, so you can, so basically you program this version and that happens. Okay. So you use the Word version and it'll extend to the the symbol. Okay, so unary versions. Okay, so how it works is you have a class, and so you say this is an operator. So it's a function, but it's being represented by an operator. So the unary minus for the point class does that. So that seems pretty useful. Let's have a look at it in our sandbox. You think I could find that on a regular basis? Okay, so we're modifying the this class to add its own. Okay. Okay, so we can have, so you don't have to memorize all these. All you do is you figure out, okay, this is the format. This is where there's a list where all the different ones. I want to do a plus plus. What's the name of it? You might forget it's INC. That's okay. The basic binary operations, you're probably going to remember these. This is pretty cool. The way it represents ranges in Kotlin, and you can specify it with the range too. Percent sign used to be mod, now it's rem for remainder. Okay, so you have a class. You can say, okay, the plus operator takes in this, and it returns a counter, which is the type. Okay, so we've seen very little, and hopefully we know enough to solve the Cohen already. So what do we want here? So we're adding the function compared to, make it comparable. Oh yeah, if you look at the operator overloading, you don't individually overload less than, greater than. Instead, you overload compare to. And that overloads, that gives you all of these, okay? Okay, so we override compare to. Okay, this is ugly. We're going to have to okay, so override compare to returns an integer. Oh, we need to take in a my date, of course. Which is the other date we're talking about. So angry. Okay, so I can probably get away with simply saying return. So if I take this dot year times 366, is that going to be okay? Yeah, I think I'm going to be okay here. No, I can't. I have to look at it individually. The months are going to mess up. Okay. I'm not going to go through the coding of this. We get the idea of comparing dates, though. Let's just show the answer. Yeah, I'm confident we can all compare dates. Yeah, so that's a nice little use of the when. I wouldn't have done that. Wouldn't have made an if. That's cool. Okay, so I don't even quite get how the when's working. Anyways, if you get frustrated by certain tests, you can just show the answer and go on. Like, I don't want to play with this anymore. Range 2 is worth looking at. And I think I have 3 minutes left. Which means I don't think I have time for this. Let's try it anyways. Okay. So once a range 2, it allows you to use the dot dot. My date dot dot my date. Yeah. I'm gonna tap out, show the answer. Date range, this, what the heck? I don't even understand it. I'm done. Okay. So what I hope to have accomplished today is I hope that you see the useful features, all the thoughtful stuff that's gone into Kotlin. I hope you recognize it's worth your time to invest in looking at this language. I would suggest you start off by going through the koans yourself. Some of them are going to frustrate you because the syntax, the first time I went through it, that the Lambda syntax really got me. I'm still not great with it, but it's worth going through. There's some good tutorials out there past that once you've seen that. My next step is to start looking at these hands-on and try and just pick up one that's reasonable, get something going on with it. And I've made a couple of independent programs with Kotlin, but I find I'm mostly just programming like I am in Java and trying to slowly integrate the Kotlin ideas. I think you're going to find that Kotlin's an up-and-coming language, and that knowing it is going to set you apart from the rest of the pack. If you go to a job interview and you put on your resume, you know, Python and Java, that's great. They're both really hot languages. But if you put it on that, outside of class, I taught myself Kotlin, you do two things. One, it's a legitimate up-and-coming language, so it's useful for its own use, but you set yourself apart as someone who's willing to invest time in your own skills. Okay, there are other languages out there that are worth looking at. JavaScript jumps to mind. PHP is worthwhile, but I think Kotlin is a good general purpose language that is going to be, I think, more and more useful as time goes on. I think I have for a number of years now felt that Java is reaching the end of its life cycle. It tries to be too many things to too many people. So I hope you've enjoyed this workshop. I hope you've learned something, and I hope I've convinced you that Kotlin is a worthwhile program to look at and spend some time doing. By all means, if you have questions about Kotlin, I'm going to be still, advancing my knowledge. So if you get stuck on certain things, feel free to just send me an Edsby message. I'll be happy to get back to you and support you in your learning with Kotlin. Okay, have a great day. I hope you enjoy the rest of the hackathon.
Sure. Don't forget to upload it to the drive, the recording.
Okay, so remind me the order. When do I stop? I stop live broadcast first and then stop the recording?
Yeah.
Okay. Yeah, I'll put it to the drive. Don't worry.
All right. Yeah, thanks, sir.
You're welcome.